Hello everybody, welcome to another IZA DWF repair video. This is the second part of the repair of a Galaga bootleg arcade PCB set. In the first part video, which is linked in the description, I've shown how I replaced the missing daughter board on the CPU PCB with a much smaller one implemented with a simple and cheap CPLD. Unfortunately, nowadays, these CPLDs are in very short supply and it appears they can only be ordered with about 1 year delay. The replacement daughter board was tested on another identical board set that I repaired some time ago to make sure it's working fine. Now, after replacing the missing daughter board, the video output shows only garbage and it's completely missing the composite sync signal. During the repair of my first PCB set of this game, I have reverse engineered most of the CPU PCB schematic. In this image we can see a partial but useful schematic of the CPU reset circuitry. The main Z80 CPU gets the power on reset signal, which is generated by a simple resistor and capacitor delay right at power on. This power on step is then ORed together with another signal that's called the watchdog reset, that the main CPU itself is supposed to stop from happening by making access to a specific I/O location at regular intervals. When everything looks fine to the main CPU, it will lift the reset signal to all other CPUs present on the game board with another I/O port access. So let's check the main CPU reset signal on pin 13 of UN6. It remains low. This is not correct. Now I want to check if the power on delay works. We should see a low to high step on pin 8 and 9 of UN6 that is wired as a simple NOT gate, so the output should make the opposite high to low transition. Yes, low to high on pin 8. And 10 is low. The watchdog reset delay is made with a 74LS393 counter, so this is the next thing to check. I begin checking its input clock signal on pin 1. This is surely bad, the low level remains too high. The LS393 clock is generated by a 74LS74 at UP8, so to decide if it's bad or if it's the LS393 input that's shorted, I'm going to cut pin 5 of the LS74 and see how the unloaded signal looks like. Pin 5 cut. And no, the output signal is still bad. So I cut all the pins of this 74LS74 since it is obviously bad. I then remove the pin fragments from the PCB and install a socket and a replacement IC. Notice this bad chip brand is Fujitsu. The output signal now looks fine. And nothing changed on the video output signal. However, the power on reset signal now pulses. That is surely because the watchdog counter is not being cleared by the main CPU. I've decided now to connect my other working CPU board with the not working video PCB. Here you can see the different color of the solder mask. Now, in this situation, the video output is working and the boot code indicates an error on one of the video port RAM ICs. With the previous test, I can be sure that the video sync issue depends on some fault located in the CPU board. However, during the repair of the older set, I didn't need any reverse engineering of the video PCB. But now I have at least to understand what signals from the CPU PCB are needed to form the video sync signal. So I started to reverse engineer the video PCB backwards from the output connector. Eventually, after a few hours of probing pins, I've reached the interconnection at pin 5 and 7, so I'm going to check what I find on those two pins. Pin 1 pulses, also pin 3 pulses, pin 5 too, and pin 7 is stuck high. Now, on the schematic of the CPU board, I found that pin 7 is driven by this circuit that I partially drawn. As usual, I started probing backwards from the connector, checking all involved ICs and found no issues until I reached UN9. Pin 12 is the output and is permanently low. On input pin 1 there is a signal. Pin 2 looks good. But on pin 13 we have an invalid level. Now pin 13 of UL9 is driven by pin 8 of UL8. This time, instead of cutting the driver pin, let's check the current flowing on the pin. Pin 8 shows barely any current with respect to the other pins, so I'm sure the driver IC is bad now. Notice that the bad IC is again a Fujitsu one. I've then removed the old IC and substituted it with a good spare after soldering a socket. And now the output of UL8 works as expected. And we don't see anymore a stuck signal on pin 7 of the interconnection. So finally the video sync issue is solved, but the CPU board is not booting yet. Since the main Z80 is not yet resetting the watchdog counter, let's just check if this address decoder in position UA1 is showing any activity, since this is precisely the one that decodes the watchdog reset port address. Input signals show some activity. But some output pins seem like just floating. Yeah, this must be bad. So I pulled that LS138, and of course it was a Fujitsu one, and replaced it with a good spare. Now all outputs show valid levels. However, the game is not yet booting. Now the main CPU reset is not toggling anymore. But it is not lifting the reset pin of all the other CPUs yet. Now, the previous LS138 was the first address decoder I've checked, but the CPU board has a few of them. Another important one is UF9, that is part of the communication interface with the 4th CPU, so let's check also this one. Here it is. Let's check the output. This is okay. This one too. Here we are. This is just floating, and yes, it's another Fujitsu. So I've replaced also this 74LS139. Now I hope that the bad ones are less than the working ones, really. Of course now all the needed outputs have a valid logic level. The very good news is that finally the game self-test reaches the RAM3H error that we have seen when using a working CPU PCB. Other people repairing this arcade bootleg figured out already what RAM IC corresponds to each self-test error indication. So, for example, on this page of ocarcade.com, we see that RAM3H error is indicating that the IC at U6M on the video board is faulty. Or is it really? Since I don't usually trust too much the built-in self-test codes of the old days, I took some time to first reverse engineer part of the schematic around the video board RAM ICs. This is not really complete, but I can really see that the same data bus transceiver is shared with other ICs that need to be tested too. Then I checked for any bad signal driving the RAM selects, the addresses and write pins, but I found no obvious issues. So at this point I decided to trust the self-test indication and just replace the 2114 RAM at UM6. And now look at this. Okay, not so fast. Left and right don't work, only 5 appears working. Notice also there is no ship explosion sound. So we aren't yet done with it. The CPU that controls both the game inputs and the explosion sound is the Z80 in position UF5. Here we see part of the input schematics. We see that player 1 left and right inputs are read by a transceiver addressed at 2000 hexadecimal location. Instead, the player 1 far input that is working is read by another transceiver addressed at 3000 hexadecimal. Then, let's also have a look at the explosion sound. We see that the output that triggers the sound is also mapped at 2000 hexadecimal, but on write access, while the not working inputs, of course, are only addressed during read cycles on the same location. Both the read and write enabled signals at 2000 have in common the same input produced by yet another 74LS138. That is the first suspect in this case. Here it is, the usual floating output, another bad Fujitsu. I have replaced also UJ7, so let's see what happens now. The best way to check the inputs is toggling the service switch, so right and left can select a sound and we can trigger that sound with the fire input. The explosion sound is the number 17 and it works fine now. And of course, the game starts to be playable now. Another mysterious fault that most of the time fixed itself as the boards warmed up is the top of each sprite missing. I call sprite all the moving objects of the game, so all the aliens and the spaceship. Notice how the top part flickers and reappears sometimes. I think this fault won't be easy to identify. However, at some point, the game didn't start anymore. Instead, the boot process stopped with an upside-down replica of the test service screen. Anyone familiar with the Galaga repairs knows that this usually happens when the auxiliary microcontroller stops working. On this bootleg, however, the custom microcontroller has been replaced with a regular Z80 CPU in position U5F, with its own RAM, ROM and I/O buffers, so I started checking the various select signals on the RAM, ROMs, and everything looked inactive. Going backwards through the select logic, I reached UA8 that buffers both the memory write and memory read signals from the Z80. This is the buffered read signal, and of course it doesn't reach 0 volts anymore. So the bad 74LS244, that of course was a Fujitsu one, has been replaced with a spare one. That made the board start again. In this footage, the sprite problem is not showing, but notice later on that the spaceship flickers slightly in the middle. I believe this is part of the same issue that I still need to address. So it is time to get back to the sprite issue. First, I've determined that the issue was in the video PCB, as swapping my other good video PCB will not show the fault. I then identified the ROM containing the sprite images by removing them one at a time. When the sprite ROM is removed, all the moving objects turn to solid rectangles. I then started reverse engineering the video schematic from the sprite ROM, which is the one located at UA6 in the video PCB. As usual, as I progressed in the schematic, I checked the various signals for any hint of a problem. This time I spent a few days worth of spare time, since I had to wait for the problem to appear, or rather to not disappear. Eventually I reached this 74LS74 in UA2. Let's probe its outputs. That doesn't look good. So another Fujitsu TTL IC needed to be replaced. At this point, the sprite fault did not show up anymore, but I've left one of the strangest issues I've ever seen as the last one. Here's what randomly happens. Let's power on. Basically, the game board doesn't start at power on. This happens randomly, either with the board warm or cold. The main CPU runs and clears the watchdog reset timer, but never progresses into the boot sequence. If I manually reset the board by grounding this pad, everything works fine as long as I've been able to test. Now, I've also tried to substitute one of my good PCBs in the set, and this issue only happens by combining these two particular PCBs. If any of the two boards is swapped with my other ones, it always starts fine. I've also checked for any difference with my other game set, but they are almost identical. Only a couple of timing capacitors were different, but changing them didn't make any difference in this behavior. I've also tried to increase the power on reset delay, but that made the issue appear more often instead of eliminating it. I have discussed this issue on OssiArcade.com forum, and one expert there reminded me that these bootlegs are known to be really choosy on the brand of Z80s that work on them. He said that some board sets would only work with the NEC D7080C/1 CPUs, and indeed, all but the input-output CPU on this board are the right ones. However, substituting the sharp Z80 with another NEC one didn't really help. Finally, I had a really desperate idea. When the boot process hangs, only the main CPU is executing code. Why not swap the main one with just another one? For all I could test, that Z80 was, however, working fine, so I've just exchanged the third and the first CPU on the game PCB. And that did the trick. Now the boardset starts at power on every time. So I played for a total of a few hours in different days, and all seemed stable. This board now is for sale or swap if anyone is interested. This was really a long troubleshooting. I hope it was interesting to you and that you learned something. If you have any question, please use the comment section below. That's all for now. Have a nice time and thank you for watching.